with Kevin Winter, who's an expert on water issues at the University of Cape Town, based in the Department of Environmental and Geographical Sciences. And we're going to talk about a concept which is around water-sensitive urban design. I wonder if you could explain what this sort of concept of water-sensitive urban design or water-sensitive cities or towns actually involves.
Yeah, so we'll use the concept of water-sensitive cities. The idea of sensitivity is quite a strange one, and it probably surpasses to some extent, arguably, words like sustainable, resilient and adapting cities to changing circumstances. But essentially it's been able to take a multidisciplinary approach to understanding how we manage water in a city, and in particular trying to close the loop on water within the city. So we look at the entire cycle of water within the city, from input through to processing, storage within the city, and also to deal with the output. So thinking it as a system is, I guess, the best way we can think of water in a water-sensitive environment. And the way we manage it, the way we think about it, and the way we extract even resources from that water before it finally is discharged if it needs to be.
Okay, so how might that way of thinking be different to sort of business as usual in a city at the moment?
Well, the business as usual approach is one of conventional drainage. Essentially, things are put into a pipe, so water comes in to the city, reaches particular destinations through a tap. It gets used in various ways, and then finds its way into a pipe after that, into a sewage treatment works. And in other cases, it falls on top of the city and is piped out as soon as it can through a system into a stormwater drainage reticulation system, and eventually goes out to rivers, to wetlands, and to the sea, if in the case of Cape Town.
So how might a water-sensitive design be different to that then?
Yeah, so you begin by really looking at a city as a catchment, and that's for the city of Cape Town as a good example, where our catchments lie some distance away from us in the mountainous regions. But actual fact, when we're starting to think about a water-scarce environment, about 3 to 4 times as much rainfall falls on the city of Cape Town as a catchment, as a city, than what we actually need. In terms of our actual demands of the city. So now you start thinking differently about how you're going to manage that water. And you begin usually by what's at source and how that water falls onto the city. And you start thinking about, well, can we slow down the speed with which that water is falling onto the roofs, onto roads, and to other hardened surfaces? Can we capture that water before it actually becomes stormwater? So the rainwater becomes crucial to building the capacity to store water locally within the city, and then to see how water then is treated in a stormwater system other than a pipe. So we use things in terms of urban design like swales, which are soft, natural conduits to processing water, and we fill those with various things, from wetlands to rocks to different media, natural media, which can slow down and also improve the quality of the water before it eventually reaches its discharge destination.
So if one was thinking about an individual in a household, what would a water-sensitive household look like? For instance?
So like anything else, you begin in a water sensitivity by knowing what kind of water you are using in your home. And so the basic audit, knowing your numbers, is a crucial way to start addressing the management of systems within your home. And water sensitivity then would be, in a home situation, would be to take grey water, for instance, and to maybe even sanitize that, to plumb the home so that the toilet sanitation systems are all driven by water which is reused.
So you mean your bath water would go into a tank that would then go into be used in the toilet or something?
Yeah, indeed. So it would be, you'd have a submersible pump in some facility nearby, and you'd be able to take it back into the toilet system, and if possible, to even sanitize that water as well. So the reuse of water in the home would be, there's lots of opportunities, but there's an obvious one. And then grey water reuse, again, for outdoor use as well. That would be some of the thinking in terms of redesigning of a home. And it also goes to the point, and it's a very important one in terms of climate change, is to ensure that outdoor gardens, we can still call on them and enhance them and create biodiversity within a neighborhood. And you do that by obviously using less water, using water-wise gardening, but by simple mulching and composting and so on, you retain a whole lot of the moisture within the soil.
So it's like conservation agriculture for gardens.
Absolutely, and with the intention of maybe building a biodiversity within your own garden, within your own neighborhood. And it is amazing how that begins to change, not only the cooling effect that has on the neighborhood, but also bringing a greater species, diversity of species into the neighborhood.
Yeah, so it's got lots of co-benefits, basically, is what you're saying. Yeah.
Sure.
So, I mean, it all seems like pretty, almost like a no-brainer that this should be happening. So why are cities not like this already?
It's fascinating, isn't it, that we are, our cities have been governed in a particular way. The paradigm has not shifted. We still remain in the conventional, wasteful approach. It requires institutional change. It requires champions. It requires good exemplars out there. And all of those are some of the things that would help to bring about this new paradigm. And that's, I think, the shift that's required.
Because, I mean, a lot of people talk about the difference between retrofitting an existing system and sort of if you've got a new suburb you're putting in, then building in that kind of, those principles is a lot easier, I presume.
Absolutely. It's much easier to do a green fields, a new development installation than it is to retrofit. And sometimes the retrofitting obviously does work, it does help. We're in a syndrome almost which is about conserving water, and its resilient approach which it almost implies we are going to just knuckle down and it's going to be a painful process. The concern around valuing and the concept of enjoying the water is what our city should begin to start looking at.
Yeah. So I just want to shift a little bit now. So at the moment about 30% of the African population is living in urban areas, and still at the moment just under 2/3 are in rural environments. Many of them don't have access to clean or safe water. And I was just wondering if some of these principles of water-sensitive cities could be applied to the village or the household scale, and whether there are kind of low-cost win-win situations that would improve the reliability and the quality of water supply to rural communities.
Sure. So I think that if across the African continent the idea of rain harvesting is well known, it's in so many places. Obviously some parts of Africa are struggling in terms of the water tanks and the storage capacity and so on. Water quality is probably where the real nose hits the rubber here, because that's an important intervention that water-sensitive designs and technologies can assist in doing.
In what way?
So here's an example, and it's in the use of biofiltration cells, which is a very simple idea of a trench or and it depends on the size of water we obviously want to try to treat. But using natural media like stones and phytoremediation of putting plants within a stone bed, using this as a sort of a constructed wetland. We currently have a very similar experiment at a very large scale where we are treating water almost to drinking standards coming off the discharge off an informal settlement near Cape Town. And we're processing treating water about 40 to 50,000 litres rather on a weekly basis. Wow. And that water won't necessarily be going to drinking, but certainly it's safe water for agricultural production. And we start in small agricultural food security centre around that.
So what sort of size is that filtration wetland, or whatever you want to call it?
So this is a very, very large wetland in this particular case, because we are accepting anything up to about 100,000 litres a week. And processing about half of that. It's retained in these very large cells. So it's at a very different scale.
Now,
but you could bring
I'm sort of interested in what sort of square meterage of wetland you need per, say, litre of water or something like that?
So in putting in those terms, 16 meters by 16 by 3.5 meters is the size that we're working with. So very large swimming pools that are about 1 meter deep. And we are able to, each one of those cells is able to contribute about 7,000 litres of water per week.
Okay, so that could serve a village essentially.
Oh yes,
in a rural area.
Indeed.
Yeah. Wow, that's really interesting. So in one sense, some of these more high-tech solutions that people try and bring out into villages might be better replaced or at least complemented by some of these more natural approaches.
For a number of reasons, and one of those is that the maintenance of high-tech solutions are not easy to cope with.
Yeah.
You also need power to be able to treat that water as well if you're going to work in a technical equipment. So these are passive. The water literally flows through gravity, tanked, and the gravity flows then into these filtration cells. And then there is maintenance, but it's probably maintenance that occurs. But essentially, it's a passive system that probably 3 or 4 years maybe before we actually have to take out the medium and refresh it, clean it out, and so forth.
In the lectures that we've been having up to now, we've been talking about how water security is around both supply and demand. And from what you've been saying, taking a water-sensitive urban design sort of approach actually deals with both of those, because you're using, so households could be using water that they have more effectively, capturing rainwater, and that would actually then reduce demand on the formal water supply system. And then you're also, through water-sensitive demand, actually augmenting the natural supply system as well. So it's dealing with both sides of the demand and supply equation.
You summed it up very well. And I'd add just one more thing too, which is interesting, particularly on the Cape Flats, where we do have a very high water table in some parts, where low-cost housing and informal settlements in particular are vulnerable to that very high groundwater.
Yeah.
And so what the possibility might be in terms of managing that aquifer, and it's called managed aquifer recharge as a concept, and the idea of trying to abstract at a particular moment in the course of those winter rainfalls to be able to take that water and distribute it into our many detention ponds that we have around the city, and to allow that water to slowly slip away into the ground during the post-winter rainfall into the summertime when we need the water most of all. But what that could do would be to try and reduce the high levels of groundwater that impact on people's lives and their health during the wet winters.
So it's also got, I guess, benefits from other benefits outside of just pure water, but people not having essentially their shacks flooded as the water table rises in winter. Kevin, thanks very much for making the time to talk about this. It's been really interesting to get the insights of your many years of working on water issues.
Thanks for the chat.
It's a pleasure. Thank you.